This is the EdExcel AS Level Further Maths Paper 1 from the 2023 series, and this paper will cover the Corpio section. Question number 1. We are given the matrix X, Y, 9, Z, subtract 3 multiplied by the matrix Z, Z, Y, Y, and this is equal to K multiplied by the identity matrix. X, Y, Z and K are constants. We have to determine the value of X, the value of Y and the value of Z. To begin with, we have our matrix X, Y, 9, Z. We then subtract 3 multiplied by the matrix Z, Z, Y, Y, and this is equal to K multiplied by the identity matrix. The identity matrix is given by 1, 0, 0, 1. Now, on the left hand side, we have X subtract 3 multiplied by Z. Then we have Y subtract 3 multiplied by Z. We then have 9 subtract 3 multiplied by Y. We also have Z subtract 3 multiplied by Y. So the left hand side simplifies to the matrix X subtract 3Z, Y subtract 3Z, 9 subtract 3Y, Z subtract 3Y. And on the right hand side, if we multiply the constant K by the identity matrix, we end up with K, 0, 0, K. If we now compare the elements of the matrix, we have X subtract 3Z, which is equal to K. We then have 9 subtract 3Y equals 0. We also have Y subtract 3Z equals 0. We also have Z subtract 3Y equals K. And with these equations, we can find X, Y, Z and K. If we have 9 subtract 3Y equals 0, we can solve for Y. 9 will equal 3Y, in which case Y will equal 3. Now that we know what Y is, we can use this to find out what Z is. We have 3 subtract 3Z equals 0, and if we solve for Z, Z is equal to 1. Now that we know what Y and Z are, we can use this to find K. We have 1 subtract 3 multiplied by 3 equals K, so K is negative 8. Now that we know what K and Z are, we can use this to find what X is. We have X subtract 3 multiplied by 1 equals negative 8, in which case you can see X is negative 5. So we have X is negative 5, Y is 3, and Z is 1. Question number 2. F of Z is equal to Z cubed plus AZ squared plus BZ plus 175, where A and B are real constants. Given that negative 3 plus 4i is the root of the equation f of z equals 0, for part A, we have to determine the value of A and the value of B. To begin with, for part A, if z1, one of our roots, is equal to negative 3 plus 4i, then we have another root which is the complex conjugate of this. In other words, we have another root z2 which is equal to negative 3 subtract 4i. z1 and z2 are complex conjugates. So for our quadratic factor, we would have z subtract negative 3 plus 4i, and then we also have this being multiplied by z subtract negative 3 subtract 4i. So what we can simplify this to is z plus 3 subtract 4i being multiplied by z plus 3 plus 4i. And what you can hopefully recognize is we have a difference of two squares. We have this being the same as z plus 3 all squared plus 16 negative 4i multiplied by 4i is positive 16. And this will simplify to z squared plus 6z plus 25. So what we have then is z squared plus 6z plus 25 being multiplied by z plus alpha, where alpha is our other root, and this will be equivalent to z cubed plus az squared plus bz plus 175. Now, for us to find out our other root alpha, we can compare the coefficients of the number terms. So, we have 25 alpha equals 175, and if that's the case, then alpha is equal to 7. And knowing that alpha is equal to 7, we can then say we have z squared plus 6z plus 25 multiplied by z plus 7, which is equivalent to the z cubed plus az squared plus bz plus 175. And if we compare the coefficients of the z squared terms, on the right hand side we have a of them, and on the left hand side we have z squared multiplied by 7 plus 6z multiplied by z. So we have 13 z squared on the left hand side, meaning a is equal to 13. And if we compare the z's, on the right hand side we have b of them, and on the left hand side, well, we have 6z multiplied by 7 plus 25 times by z equals the b. So we can solve for b. B is 67. And knowing what the values of a and b are, we can then conclude f of z is equal to z cubed plus 13z squared plus 67z plus 175. Part b. Show all the roots of the equation f of z equals 0 on a single Argand diagram. Well, for part b, we have f of z equaling 0, which has roots z1 equals negative 3 plus 4i, z2 equaling negative 3 subtract 4i, and z3 equaling negative 7. And if we wish to sketch these on our Argand diagram, well, here is our Argand diagram. We have z1 shown here, negative 3 along the real axis, 4 up in the imaginary axis. We then have z2, negative 3 along the real axis, and 4 down the imaginary axis. And then we have z3, which is just negative 7 along the real axis. So here is our Argand diagram, and here are our roots represented on the Argand diagram. Part C. Write down the roots of the equation f of z plus 2 equals 0. First of all, we are going from f of z to f of z plus 2. And what this is a translation by vector negative 2, 0. So what we have to do with each of these roots is subtract 2 from them. And if we do that, you will find f of z plus 2 equaling 0 having roots z equals negative 5 plus minus 4i and negative 9. Question number 3. We have the matrix A 1 0 0 0 root 3 over 2 1 half 0 negative 1 half root 3 over 2. Part A, we have to describe fully the single geometric transformation A represented by the matrix A. For part A, we have to derive the rotation matrix. Using the right-hand rule, we have an XYZ coordinate grid with the points 1 0 0, 0 1 0 and 0 0 1 plotted. Now, if we take a look at the matrix we are given, you will notice we have 1 0, 0. And then in the y direction, we have 0 here, and in the z direction, we have 0 here. This suggests to us we are rotating in the x direction. And if that's the case, then looking down the x-axis, we see the yz axis, as we see here. Now what happens is, if we take this point 0, 1, 0, we will be rotating this point. So, if we rotate it to this point, say, what would the coordinates be? Well, along the x direction, that's not changing. But along the y direction, we go this many across, which is 1 cos theta. And in the z direction, we have 1 sine theta. And similarly, if we rotate this point by theta, well, what will be the coordinates of this point? Well, along the x direction, that's not changing, so that's going to remain as 0. But along the y direction, we have negative 1 sine 0. And along the z direction, we have 1 cos theta. Meaning, the rotation about the x-axis by an angle of theta is given by this matrix 1, 0, 0, that's the x's, and in the y's, we've got 0 cos theta, sine theta, and in the z, we've got 0 minus sine theta, cos theta. So here where we've got the cos theta, we can compare that directly with the root 3 over 2, in which case you can see theta will equal 30 degrees, meaning you have a transformation A, which is a rotation by 30 degrees in the x direction. Part B, we've got this matrix 1 root 3, 1, 3, 0, 2, 0, 5 root 3, 0. The transformation B is represented by the matrix B. The transformation A followed by the transformation B is the transformation C, which is represented by the matrix C. To determine matrix C, a student attempts the following matrix multiplication. What they have done is 1, 0, 0, 0 root 3 over 2, 1 half, 0 negative 1 half root 3 over 2, being multiplied by 1 root 3, 1, 3, 0, 2, 0, 5 root 3, and 0. We have to state the error made by the student. Well, to determine matrix C, what happened is we have transformation A followed by transformation B, and that gives transformation C. So in terms of the error that's been made, it's the order in which they multiply. To determine matrix C, they would have to do B multiplied by A to find C. So for part B, the transformations are being multiplied in the wrong order. Part C, determine the correct matrix C. For part C, we've got the matrix B being multiplied by the matrix A as shown here. And if we work this out, well, we've got the 1 multiplied by the 1 plus the 3 multiplied by the 0 plus the 0 times by the 0, that's equal to 1. We then have the 1 times by the 0 plus the 3 times by the root 3 over 2 plus the 0 times by a half, which is 3 root 3 over 2. We then have 1 times by 0 plus 3 times by negative 1 half plus 0 times by root 3 over 2, which is negative 3 over 2. We then have root 3 times by 1 plus 0 times by 0 plus 5 root 3 times by 0, which is root 3. We then have root 3 times by 0 plus 0 times by root 3 over 2 plus 5 root 3 times by a half, which is 5 root 3 over 2. We then have root 3 times by 0 plus 0 times by negative half plus 5 root 3 times by root 3 over 2, and here we need to be careful. Root 3 times by root 3 is 3, multiplying that by 5 is 15, and then we divide that by 2, so we have 15 over 2. We then have 1 times by the 1 plus 2 times by the 0 plus 0 times 0, which is 1. We then have 1 times by 0 plus 2 times by root 3 over 2 plus 0 times by a half, that's root 3. And then we have 1 times by the 0, 2 times by the negative 1/2, and the 0 times by the root 3 over 2 being added together, we get negative 1. So here is the matrix C. It's given by 1 root 3, 1, 3 root 3 over 2, 5 root 3 over 2, root 3, negative root 3 over 2, 15 over 2, and negative 1. Question number 4. For part IA, we have to show that 2 plus 3i over 5 plus I is equal to k multiplied by 1 plus I, where k is a constant to be determined. To begin with, we have the 2 plus 3i over the 5 plus I. And what we can do is essentially rationalize the denominator. What we mean by this is we have to multiply both the numerator and the denominator by the complex conjugate of 5 plus I. We have to multiply both the numerator and the denominator by 5 subtract I, as we see here. And if we begin to work this out, we have 2 times by 5, which is 10. Then we have 2 times by negative I, which is negative 2i. 3i times by 5, which is 15i. And then we have 3i multiplied by negative I, which is positive 3. And on the bottom, we've got a difference of 2 squares. 5 times 5 is 25. Then we've got I times by negative I, which is positive 1. And if we simplify this, we get 13 plus 13i over 26. We can divide top and bottom by 13, leaving us with 1 plus I over 2. And if that's the case, then we can conclude k is equal to 1/2. Given that n is a positive integer and 2 plus 3i over 5 plus I to the n is a real number, we have to use the answer to part A to write down the smallest possible value of n. So, we have this complex number given by 2 plus 3i over 5 plus I, and then we are raising this to the nth power. Now n is a positive integer, and we want the result of this when raised to the n to be strictly real, meaning we want no imaginary terms. And when n is equal to 1, we end up with 1/2 plus 1/2 I. So n cannot equal 1. Let's try the next positive integer, 2. We end up with 1/2 I. That contains an imaginary term, so what we want is something that's purely real, so let's try n equals 3. We end up with negative 1/4 plus 1/4 I. It contains an imaginary term. So now let's try the next value of n of 4. We end up with -1/4. So for part B, we have 2 plus 3i over 5 plus I to the 4 equaling -1/4. This is strictly real, meaning n will equal 4. Next, the complex number z equals a plus bi, where a and b are real constants. Given that the modulus of z to the 10 is equal to 59,049, and the argument of z to the 10 is equal to -5 pi over 3, we have to determine the value of a and the value of b. To begin with, if z is equal to a plus bi, then z to the 10 is equal to a plus bi to the 10. And what we can do is rewrite this using Demoivre's theorem. We can rewrite this as r multiplied by cos theta plus I sin theta all raised to the 10, and using Demoivre's theorem, this is the same as r to the 10 multiplied by cos 10 theta plus I sin of 10 theta. What we also know is the argument of z to the 10 is equal to -5 pi over 3. And our argument here is 10 pi for z to the 10, meaning that 10 theta is equal to -5 pi over 3, which means theta is equal to -pi over 6. What we also know is the modulus of z to the 10 is equal to 59,049. And so we can find out what r is, which is the same as the modulus of z, which is equal to the 10th root of 59,049. So if we work out 59,049 to the 10th power, we end up with 3. So r is equal to 3. We know what r is, we know what theta is, and therefore we can find out what z is using z equals r multiplied by cos theta plus I sin theta. We can therefore conclude that z is equal to 3 multiplied by the cos of -pi over 6 plus I sin of -pi over 6. So if we work this out, well, what we will end up with is 3 root 3 over 2 for the real part, and for the imaginary part, we end up with -3 over 2. And if that's the case, then a is equal to 3 root 3 over 2 and b is equal to -3 over 2. Question number 5. A large pile of concrete waste is created on a building site. Figure 1 shows a central vertical cross-section of the concrete waste. The curve C, shown in figure 2, has equation y plus x squared equals 2, where x is in between 0 and root 2. The region R, shown shaded in figure 2, is bounded by the y-axis, the x-axis, and the curve C. The volume of concrete waste is modelled by the unit of revolution formed when R is rotated through 360 degrees about the y-axis. The units are meters. The density of the concrete waste is 900 kilograms per meter cubed. Part A. Use the model to estimate the mass of the concrete waste. Give your answer to 2 significant figures. To begin with, we know that when x is equal to 0, we have y plus 0 squared equals 2, which means y is 2. And if I show this on the diagram, we've got the 2 over here. And if we consider the x equaling root 2, we have y plus root 2 squared equals 2, in which case y is 0. Now, to find the volume, we would have to integrate pi multiplied by the integral of x squared with respect to y from 0 to 2, because these are our limits and we are rotating by 360 degrees about the y-axis. And we know what the equation C is, that's y plus x squared equals 2, and if I rearrange, you can see x squared is equal to 2 subtract y. So what I can now do is replace the x squared with 2 subtract y. So I'm integrating 2 subtract y with respect to y from 0 to 2, and I'm multiplying that by pi. So if I work this out, we have pi multiplied by, well, integrating 2, we end up with 2y, and integrating negative y, we end up with negative y squared over 2. And this is being evaluated between 0 and 2. So if we continue to work this out, what we end up with is 2 pi meters cubed as our volume. So therefore for the mass, we have 2 pi, which is the volume, multiplied by the density 900, which is 1800 pi. And if we work this out to two significant figures, we have 1800 pi, which as a decimal to two significant figures, we have 57,000 kilograms. Part B, we have to give a limitation of the model. Well, the pile of concrete waste is unlikely to be perfectly symmetrical. The mass of the concrete waste is approximately 5,500 kilograms. You have to use this information and our answer to part A to evaluate the model, giving a reason for your answer. Well, what we can do is compare this 5,500 with this 5,700. So by that, what we can do then is work out a percentage error. We've got the 1800 pi, subtract the 5,500 over the 5,500 multiplied by 100. And if we work out what this is, we have 1800 pi, subtract 5,500 divided by 5,500. And if I multiply this by 100, it turns out we get 2.81 etc%. That's actually quite small, so it's a good model to use. Question number 6. The line L1 has equation r equals -220 plus lambda multiplied by 301, where lambda is a scale parameter. The line L2 is parallel to 1 to -3. We have to show that L1 and L2 are perpendicular. Well, for us to show that L1 and L2 are perpendicular, we have to take the scalar dot product between the direction vector 301 and 1 to -3. So we've got 1 to -3 dot with 301, and if we work this out, well, we have the 1 times by the 3, we add on to this the 2 times by the 0, we add on to this the -3 times by the 1, and if we work this out, we get 0. And because the scalar dot product is 0, we can therefore conclude the lines are perpendicular. The plane pi contains the line L1 and is perpendicular to 1 to -3. We have to determine a Cartesian equation of pi. So, for part B, we begin with a diagram. We've got our plane pi. The line L1 is on the plane pi. We know on L1 the point -220 lies on it, and that is what's shown here, and therefore the point -220 also lies on the plane pi. and the plane is perpendicular to I plus 2j subtract 3k. We know that plane through A with normal vector n equals n1i plus n2j plus n3k has Cartesian equation n1x plus n2y plus n3z plus d equals 0, where d is equal to negative a dot with n. And so using that information, we can say then pi is given by x plus 2y subtract 3z equals some constant d, where the coefficients of x, y and z is the normal vector. Now we know that negative 2 to 0 lies on pi, and so if we substitute this point into here, we can find out what d is. So d is equal to negative 2 plus 2 multiplied by 2, subtract 3 lots of 0, we will find d to equal 2. And if that's the case, then pi has equation x plus 2y subtract 3z equals 2. For part C, we have to verify that the point A with coordinates 3, 1, 1 lies on pi. For part C, we've got the point A 3, 1, 1, and if we substitute these into here, on the left hand side we've got 3 plus 2 times by 1, subtract 3 times by 1, which is 2. And that's what we have on the right hand side. So the point A with coordinates 3, 1, 1 lies on the plane. Given that the point of intersection of pi and L2 has coordinates 2, 3, 2, the point B has coordinates P, Q and R, and B lies on L2, and the distance AB is 2 root 5, and P, Q and R are positive integers, we have to determine the coordinates of B. Here is our updated diagram. We've got the point A, which lies on the plane pi. We've got the line L2, and on L2 we have the coordinates B, P, Q and R. The intersection of L2 and the plane pi is given by 2, 3, 2. Now, what we can do is find the equation of L2. We know it passes through the point 2, 3, 2, and its direction vector is parallel to I plus 2j subtract 3k, so we add on lambda multiplied by I plus 2j subtract 3k. And if that's the case, then we can find out what the coordinates of B are in terms of lambda. And if we do that, you can think of this as going from the point 2, 3, 2 to some general point, which means then B would have coordinates 2 plus lambda, 3 plus 2 lambda, 2 subtract 3 lambda. So if we now find the vector AB, we are starting at A and we are finishing at B. That's equal to OB subtract OA. So we have 2 plus lambda subtract 3. And we have 3 plus 2 lambda subtract 1. And 2 subtract 3 lambda subtract 1. And if we work this out, in the I direction we have negative 1 plus lambda, in the J direction we have 2 plus 2 lambda, and in the K direction we have 1 subtract 3 lambda. We now know enough information to find out the magnitude of AB. The magnitude of AB, that's given by negative 1 plus lambda squared plus 2 plus 2 lambda squared plus 1 subtract 3 lambda squared, and this is equal to 5 root 2, that's given in the question. And if we square both sides, we would have negative 1 plus lambda squared plus 2 plus 2 lambda squared plus 1 subtract 3 lambda squared, that's equal to 20. And if I expand out, well, negative 1 plus lambda all squared is lambda squared subtract 2 lambda plus 1. 2 plus 2 lambda squared is 4 lambda squared plus 8 lambda plus 4. And 1 subtract 3 lambda squared is 9 lambda squared, subtract 6 lambda plus 1. And this is all equal to 20. And if I simplify, we end up with 14 lambda squared equals 14. So lambda is equal to plus minus 1. But we know then P, Q and R are positive. And if that's the case, what we want is positive values of P, Q and R. Now if I have 1 for lambda, I'd have 3. Here I would have 5. And here I'd have negative 1. So lambda equals 1 doesn't work. But if I had negative 1, then here I'd have 1. Here I'd have 1. And here I would have 2 subtract 3 times negative 1, which is 5. Which means lambda equals negative 1, because that ensures P, Q and R will be positive. So the coordinates of B, we've got 1, 1 and 5. Question number 7. For the first part, we have to shade on an Argand diagram the set of points for which the mod of z subtract 3 is less than or equal to the mod of z plus 6i. For part A, we can rewrite this as the mod of z subtract 3 plus 0i being less than or equal to the mod of z subtract 0 subtract 6i. These are equivalent. What we require is the perpendicular bisector. So, we can begin by finding the gradient that's equal to 0 subtract negative 6 over 3 subtract 0, which is 2. So for the perpendicular gradient, that's going to equal negative 1/2. And if that's the case, then we can now find the midpoint, because we require the perpendicular bisector. The midpoint is given by 3 plus 0 over 2 in the x direction, and 0 plus negative 6 over 2 in the y direction. So the midpoint is given by 3 over 2, negative 3. Now, we can use y minus y1 equals gradient multiplied by x minus x1. So we have y subtract negative 3 equals negative 1/2 multiplied by x subtract 3 over 2. So therefore the perpendicular bisector would have equation y equals negative 1/2 x subtract 9 over 4. And if we sketch this and shade as required, we have this situation here. For the next part, we have to determine the exact complex number w which satisfies both the argument of w subtract 2 equals pi over 3 and the argument of w plus 1 equals pi over 6. For part B, we've got the argument of w subtract 2 equals pi over 3. And if we work out the tangent of pi over 3, we get root 3, which means we can rewrite this as y equals root 3 multiplied by x subtract 2. We'll call this equation 1. And if we've got the argument of w plus 1 equals pi over 6, well, if I actually work out what the tangent of pi over 6 is, we get root 3 over 3, which means we can rewrite this as y equals root 3 over 3 multiplied by x plus 1. So now, if I call this equation 2, to find the complex number which satisfies both the argument of w subtract 2 equals pi over 3 and the argument of w plus 1 equals pi over 6, we can solve equation 1 and 2 simultaneously. And in doing so, setting them equal to each other because they both equal y, we've got root 3 multiplied by x subtract 2 equals root 3 over 3 multiplied by x plus 1. So we've got 3 multiplied by x minus 2 equals x plus 1. So we have 3x subtract 6 equals x plus 1, which means x equals 7 over 2. And when x equals 7 over 2, we can find out what y is. Y is equal to root 3 over 3 multiplied by 7 over 2 plus 1, which is 3 root 3 over 2. And therefore w is equal to 7 over 2 plus 3 root 3 over 2 I. Question number 8, part A. We have to use these standard results for the sum from r equals 1 to r equals n of r squared and the sum from r equals 1 to r equals n of r to show that for all positive integers n, the sum from r equals 1 to r equals n of 2r minus 1 all squared is equal to n over 3 multiplied by an squared subtract 1, where a is a constant to be determined. So for part A, well, what we can do to begin with, to work out the summation, is we can first of all work out 2r minus 1 all squared. That means we have the summation from r equals 1 to r equals n of 4r squared subtract 4r plus 1. And rewriting this, this is the same as the sum of 4r squared from r equals 1 to r equals n, subtract the sum of 4r from r equals 1 to r equals n, plus the sum of 1 from r equals 1 to r equals n. Continuing with this, we can rewrite this as 4 multiplied by the sum of the r squareds from r equals 1 to r equals n, subtract 4 multiplied by the sum from r equals 1 to r equals n of r, plus the sum from r equals 1 to r equals n of 1. So if we work all this out, well, we are required to use the summation formula. The sum of the r squared is 1/6 n multiplied by n plus 1 multiplied by 2n plus 1. So I have 4 multiplied by 1/6 n times n plus 1 multiplied by 2n plus 1, and then I subtract 4 multiplied by the sum of the r's, which is given by 1/2 n times n plus 1, and then I add on n, which is the same as the sum from r equals 1 to r equals n of 1. So continuing to work this out, well, if I factorize out an n, inside the bracket, well, I've got here 4 times by 1/6, which is 2/3, and then I multiplied by n plus 1 times 2n plus 1. And then here I subtract 4 times by 1/2, which is 2, and then I multiply that by the n plus 1. And then because I've factored out an n, I add on 1. So simplifying this even further, well, I've got the n over 3, and the reason for that is because I'm pulling out a third. So I've got 2 multiplied by n plus 1 times 2n plus 1. Then I subtract 6, because 6 times by a third is 2. And then I multiply that by the n plus 1. And then I add on 3, because 3 times by a third is the 1. So continuing to work this out, I've got n over 3, and then here I have 4n squared plus 6n plus 2, subtract 6n, subtract 6 plus 3. Which simplifies to n over 3 multiplied by 4n squared subtract 1, in which case you can see a is 4. Part B, hence determine the sum of the squares of all positive odd 3-digit integers. So for part B, when we talk about the sum of squares of positive odd 3-digit integers, well, the first positive odd 3-digit integer, that's 101. And then we add on to this 103, that's the next positive odd 3-digit number. Then I add on 105, 107, and I continue this up until the final positive odd 3-digit number, which is 999. So once I add all these numbers together, what I need to do with it is square the result. So we have the sum of 2r minus 1 all squared given to us. Now we've got to think carefully about our summation. If we think about this 101, what is the connection between 2r minus 1 and 101? Well, that occurs when r is equal to 51. If I multiply 2 by 51 and then subtract 1, I get 101. And then if I think about the 999 and how this relates to the 2r minus 1, well, the 999 will occur when r is equal to 500. 500 times by 2 subtract 1 is 999. So I need to work out this sum here. And what this is the same as is the sum from r equals 1 to r equals 500 of 2r minus 1 squared. And then I subtract the first 50 terms. So I subtract the sum from r equals 1 to r equals 50 of 2r minus 1 squared. So if I use what I found here in part A, we have 500 over 3 multiplied by 4 times 500 squared subtract 1, and then I subtract 50 over 3 multiplied by 4 times 50 squared subtract 1. So let's work this out. I've got 500 over 3 multiplied by 4 times 500 squared subtract 1. Then I subtract 50 over 3 multiplied by 4 times 50 squared subtract 1. And it turns out I get a value of 166,499,850. Question 9. For the first part, we have this matrix P, k negative 3k, negative 2, negative 5k, 7, 2, 4, where k is a constant. We have to show that P is non-singular for all real values of k. To attempt this question, what we need to do is find the determinant of P, and the determinant of P is shown here. And if we work this out expanding along the top row, we have k, and then we cover up this column and this row, and we have the determinant of what's left over, negative 5k 2, 4, and then we subtract negative 2 multiplied by, well, we'd have the determinant if I cover up this column and this top row. The determinant of what's left over is negative 3 2k 4, and then I add on 7 multiplied by, well, if I cover up this column and this top row, the determinant of what's left over, I've got the negative 3, negative 5k and k. If I work this out, well, I've got k, and then here I've got negative 20 subtract 2k. Then I add on 2 because negative 2 is positive 2. And then here I've got negative 12 subtract 2k. And then I add on 7. And then here I've got negative 5k subtract negative 3k, as we see here. So simplifying all this, we end up with negative 2k squared subtract 10k subtract 24. We want to show that this is not equal to 0. So if we use the discriminant, we've got negative 10 squared subtract 4 times negative 2 times negative 24, which is negative 92, and because this is less than 0, it doesn't equal 0 for real values of k, which means P is non-singular. Next, we've got this matrix Q, 2, negative 3, negative 1, 0. The matrix Q represents a linear transformation T. Under T, the point A with coordinates A2 and the point B with coordinates 4, negative A, where A is a constant, are transformed to the points A' and B' respectively. Given that the distance A' B' is root 58, we have to determine the possible values of A. So, for part B, we begin with finding out what A' is. I've called the x coordinate xa' and the y coordinate ya'. I've got this coordinate which I need to apply the transformation to. So I multiply q by that coordinate a2. And if I work this out, well, here I've got 2 times by a plus negative 1 times 2. So that's 2a subtract 2. And then I've got negative 3 times a plus 0. So here is the coordinate of a'. Let's find out the coordinate of b' in a similar way. I've got q multiplied by the coordinates of 4, negative a. And if I work this out, I've got 2 times by 4 plus negative 1 times negative a. And then I've got the negative 3 times by 4 plus 0 times by negative a. So I've got the coordinates of b dash being 8 plus a, negative 12. So I've got a dash and b dash, and now I can find the distance. Well, the vector a dash b dash, that's equal to 8 plus a, negative 12, subtract 2a subtract 2, negative 3a. If I work this out, I end up with 10 subtract a, negative 12 plus 3a. So now finding the distance, we've got the square root of 10 subtract a all squared plus negative 12 plus 3a squared. And what I know from the question is that the distance is 58. Square rooted, as we see here. And if I square both sides, I've got 10 subtract a all squared plus negative 12 plus 3a squared equals 58. And expanding this bracket, I've got a squared subtract 20a plus 100. And expanding this bracket, I've got 9a squared subtract 72a plus 144. That's equal to 58. And if I simplify, I end up with 10a squared subtract 92a plus 186 equals 0, which means if I attempt to solve for a, we can use our calculator for this. I've got 10a squared subtract 92a plus 186, so I get 31 over 5 and 3 as the values of a. Question number 10. The quartic equation z to the 4 plus 5z squared subtract 30 equals 0 has roots p, q, r and s. Without solving the equation, we have to determine the quartic equation whose roots are 3p subtract 1, 3q subtract 1, 3r subtract 1 and 3s subtract 1. We have to give our answer in the form w to the 4 plus aw cubed plus bw squared plus cw plus d equals 0, where a, b, c and d are integers to be found. To begin with, if we let w equal 3z subtract 1 and then rearrange for z, we would have z equals w plus 1 over 3. And what we can do with this is substitute it into this quartic equation. We will then be left with a new equation in w. So for our new equation, we have w plus 1 over 3 to the 4 plus 5 lots of w plus 1 over 3 squared subtract 30 equals 0. And if I multiply through by 3 to the 4, we have w plus 1 to the 4 plus 45 lots of w plus 1 squared subtract 24, 30, this is equal to 0. Now if I expand w plus 1 to the 4, I've got w to the 4 plus 4w cubed plus 6w squared plus 4w plus 1. If I expand the 45 times w plus 1 squared, well, I've got 45 multiplied by w squared plus 2w plus 1, and then I subtract 24,030, and that's equal to 0. And then if I simplify this, we will end up with w to the 4 plus 4w cubed plus 51w squared plus 94w subtract 2384, and this is equal to 0. So we see then a is 4, b is 51, c is 94, and d is minus 2384. Next, the roots of the cubic equation 4x cubed plus nx plus 81 equals 0, where n is a real constant, are alpha, 2 alpha and alpha minus beta. We have to determine for the first part the values of the roots of the equation and then the value of n. So, for the next part, we've got 4x cubed. Now I'm going to add on this 0x squared, and it will make sense why in a sec. Then I add on nx, then I add on 81, and this is equal to 0. If I divide through by 4, I end up with x cubed plus 0x squared plus n over 4x plus 81 over 4 equals 0. What I can now do is find the sum of the roots. Now the sum of the roots, I've got my roots alpha added to 2 alpha added to alpha minus beta. And this is equal to negative 0. So we see then beta is equal to 4 alpha. We can now find the product of the roots. I've got alpha multiplied by 2 alpha multiplied by alpha minus beta. That's going to equal negative 81 over 4. So therefore, I've got alpha multiplied by 2 alpha multiplied by alpha minus 4 alpha, because beta is 4 alpha. That's equal to negative 81 over 4, in which case we see negative 6 alpha cubed is equal to negative 81 over 4. And therefore, alpha is equal to 3 over 2. So if that's the case then, one of my roots is alpha, my other root is 2 alpha. So for my 2 alpha root, I can find out the value of this by multiplying 3 over 2 by 2. I get 3. And then to find my other root, alpha minus beta, I need to first of all find beta. So if I find beta, I need to multiply alpha by 4, leaving me with 4 times 3 over 2, which is 6. And now if I do alpha minus beta, I end up with 3 over 2 subtract 6, which is minus 9 over 2. So I've got roots 3 over 2, 3, and minus 9 over 2. And with this then, what we can say then is for our equation, we've got x subtract 3 over 2 multiplied by x subtract 3 multiplied by x subtract negative 9 over 2 equals 0, in which case we see we can rewrite this as 2x subtract 3 times x minus 3 times 2x plus 9, and that's equal to 0. So if I expand 2x minus 3 with x minus 3, I end up with 2x squared minus 9x plus 9, and then multiply that by 2x plus 9, and that's equal to 0. So let's expand everything. I've got 2x squared times 2x, that's 4x cubed, 2x squared times 9, that's 18x squared, minus 9x times by 2, which is minus 18x squared. Then I've got 9 times 2x minus 9x times by 9, which is minus 81x. And then I've got 9 times 2x, which is 18x, and then I add on the 9 times 9, which is 81. That's equal to 0. So I can simplify this. I've got 4x cubed subtract 63x plus 81 equals 0, in which case you see n is equal to 63.